practice drawing the molecules, trying to illustrate the overall molecule shape with all the bonds in there and identify the name of the shape. So the first thing to do is to draw each of the elements that are going to be present in the molecule, their dot diagram. So chlorine, its symbol is Cl. Chlorine is from group 17, so that means it has 7 valence electrons. And when I take a look at that dot diagram, that is the only unpaired electron. So that means a chlorine has to form 1 bond. Now, carbon comes from group 14. And with it, you have to remember, we do the hybrid. So I'm going to write hybrid there. So group 14, 4 valence electrons, but we do the hybrid one. So that means that we put 1 electron on each side. So that means it has 4 unpaired electrons. So carbon has to form 4 bonds. Now when you build your molecule, okay, so when you build that to come up with the shape, you have to think about the center atom. So the center atom, typically what is going to be true? Number 1, most bonds. And in comparison, it usually has the lower electronegativity. Now, one little rule, H can never be the center atom. Okay, so H is never the center as a general rule. So when I take a look here, if I go and I look up the electronegativities, chlorine has an electronegativity of 3.2 and carbon has an electronegativity of 2.6. So I take a look at this. Carbon needs 4 bonds and it has the lower electronegativity. So that means that carbon is going to be the center, what I'm going to build around. So that means I look at the Hunk rule wherever carbon is. So on the Hunk sheet, I look at the center. So in this case, it's carbon. So when I go up there to take a look, okay, so carbon is my center. So now I have to pick out which pattern is best going to be used here. So I have 1 carbon, but I have 4 chlorines. So when I take a look at it, at the end where I left the dashed line, at the end of it, that's where I can place an atom. So example number 1, I can put 1, 2, 3, 4 atoms on the carbon. And number 2, I could put an atom here at the other side of the double bond and 1 at each of the singles. So that one's only 3. In option 3, I can put an atom to the right of this double bond and a different atom to the left of this one, so I can only put 2 atoms here. And then number 4, I can put an atom to the right of the triple and an atom to the left of the single, so that's 2. So this one I can add 2 atoms to the carbon, 2 atoms to the carbon, 3 different atoms to the carbon, and this one 4 different atoms. So when I take a look, my best fit here is example number 1. So immediately I'm going to go down to my sheet. I understand this is what I'm going to have. So my carbon is going to use this center atom molecular shape to create a structure with these 4 chlorines. Electron-wise, what happens? This chlorine's only single electron can only pair up with this 1 electron from the carbon. They form their bonds. So I'm going to put it right here. So here is my chlorine, and then it keeps its 3 electron pairs for itself. So I have my first of 4 chlorines. Now I add another chlorine. The second chlorine, its only unpaired electron pairs up with carbon's second unpaired electron. So I'm going to put it down here because I'm just going to follow what I did. or where I placed it here. So now I've placed 2 chlorines around the carbon. Carbon has 2 bonds. Each of these chlorines has 1 bond. That means I've got 2 more placements to go. So here we go. Here is my next chlorine. So its single only unpaired electron pairs up with carbon's third. So I'm going to show that guy on the other side here. So the dashed line represents the electrons that are pairing up, and then the electron pairs the chlorine keeps for itself go around the outside. Now carbon here has 1 more unpaired electron. Says I need 4 chlorines, so I'm going to add 1 more here. And so this unpaired electron, this chlorine's unpaired electron, pairs up with carbon's final unpaired electron. And I'm going to place that one right here. And so because I used the pattern of carbon forming 4 different single covalent bonds, the shape or the name of this molecule would be tetrahedral. Okay. So I'm going to take a look at this next example. First I have silicon, and silicon comes from group 14, just like carbon. So it has 4 valence electrons, and it uses that hybrid state. It follows a pattern like carbon. So it has 4 single unpaired electrons. Each silicon needs to form 4 bonds. Oxygen is also present. So this oxygen comes from group 16, 6 valence electrons. So 1, 2, 3, 4, 5, 6. And when you take a look at the oxygen, there's an unpaired electron, there's another unpaired electron. So this oxygen has to form 2 bonds. So right now, silicon needs the more bonds. When I look up electronegativity values, silicon's electronegativity is around 1.9. Oxygen is 3.4. So silicon has the lower electronegativity, most bonds. So this is what I'm going to pick for my center of the structure. So I'm just going to put Si right there. So that's going to be the center, and I'm going to build around it. It's a terrible S. Okay, so now I'm going to go back to my honk sheet and figure out the pattern. So this is so when I look at the honk, because silicon is in group 14 like carbon, I'm going to look at the patterns in the C part of the honk sheet. So I take a look, okay, where C is any of these, I would replace with Si. So possibility 1 is because I have 4 atoms attached to the carbon. Example 2 is because I have 3 atoms I'm going to place around the carbon or the group 14 center atom. 3 and 4 is because I have 2 atoms to place on there. So I have to figure out 3 and 4. I have 2 silicons, which one is going to be the better fit. So when I go down and take a look, okay, this silicon, its first unpaired electron will hook up or pair up with one of oxygen's first. Oxygen still isn't happy. It needs 2 bonds. So its other unpaired electron will hook up with the silicon. So if I go to add this on, silicon will form a double bond with this oxygen, right? And oxygen keeps 2 electron pairs for itself. It tells me I have a second oxygen. Well, the second oxygen has to have a bonding pattern just like the first one. So what would make sense is that silicon would form a second double bond with the second oxygen. So because my silicon formed 2 different double bonds with 2 different oxygens, the shape would be linear.